On this video, we will talk about characteristic of exponential function. An exponential function is f of x equal b to the x power, where the base is b, the base is positive and not equal to 1. That's just the way we define it. The first part of it, we talk about the graph. In order to do that, we just have to do one example and see how the graph of each particular case will look like. First, the case when the base is bigger than 1, the other one is where the case is less than 1, but still, of course, have to be positive. Right. So I choose the easiest one possible. When b bigger than 1, let's consider the graph of the function 2 to the x power. Now we just need to put all of these x values into the exponents. So we have 2 to the negative 1. And we have the properties of exponent. I will write that here. If the exponent is negative, we can move the whole term down and turn to positive. They usually say cross the line, change the sign. So we'll do that and turn to positive, and that is 1/4. Likewise, 2 to the negative 1, 1/2 to the first power, so it's just 1/2. 2 to 0 power, anything raised to 0 power is 1. We will get back to that in a minute. 2 to the first power is itself, and 2 squared is 4. Now try to plot over this point here. Negative 1, 1/2. Negative 2, 1/4. 1 is 2, and 2 is 4. Right. We will talk more about this graph later. At this moment, what we see is that the bigger the exponent, the bigger the y values. So this function, it is increasing. When b is greater than 1, just to be sure, we just write when b bigger than 1. It's going up. We'll get back to that in a minute. Now we go to the case where the base is between 0 and 1. I will choose 1/2 to the x power. And we'll do the same thing. Evaluate all these points, find the point and put on the graph, and we'll compare with what we have on the other side. Uh, 1/2 to the negative 2 power. The power will go to the top and go to the bottom. And then negative exponent, we can move that to the top, move that to the bottom, turn to positive. That's just 2. Now 1/2 to the negative 1 power. Power goes to the top, goes to the bottom. Negative exponent, cross the line, change the sign. Sorry, that one was not 2. This one is 2. So 2 squared over 1 is 4. So that should be 4. Right. 1/2 to the 0 power. We can also do the same thing. 0 to the top, 0 to the bottom as the power. That's just 1 and 1 because everything to 0 power is 1. So write that as well. And that applies to all the bases. So we just 1. Anything to the first power is itself. And 1/2 to the second power goes to the top, goes to the bottom. We have 1 over 2 square will be 1/4. All right, and we put all of this point on the graph. -2, we have 4. Right, label them. And -1, we have 2. 0, 1, and 1 is 1/2, and 2 is 1/4. So that graph is of the function f of x equal 1/2 to the x power. Now, one thing we see right away is that this one is decreasing. So it is decreasing if the base is between 0 and 1, and increasing if the base is bigger than 1. So we have that. Next, the other properties and characteristic of exponential function. One common thing we see on both of these graphs is that anything raised to 0 power is 1. So that properties. So pretty much on the graph, we have the point 0, x equal to 0, y equal to 1. And we have that on both of the function. Doesn't matter what the base is. Right. So I will write that. The graph of f of x equal b to the x always crosses the point 0 and 1. So that's one common characteristic. The other characteristic is you see, doesn't matter what we choose the base, whatever we choose for the exponent, the y value is always positive. It could get close to 0, but it cannot get to 0. So we say that the function f of x equal b to the x is always positive. Or we should say greater than 0. And because of that, it is positive. If we keep the value of x becomes -3 and gets smaller and smaller, the graph will get closer and closer to the x-axis, but will not touch. So in that case, what we have is the horizontal asymptote. Is the line, the x-axis, or y equal to 0. The same thing here. It can get closer and closer to the x-axis, but will never touch. And we have the horizontal asymptote is y equal to 0. To summarize, we say the function is always positive, and the line y equal to 0, which is also the x-axis, is the horizontal asymptote. And that are some characteristics. Just want to put one thing real quick along this line. If that is the function is always positive, so we can write out the domain and range of those functions as well. So we will have the domain the domain, we can put any values for x, could be negative, could be positive. So we go from negative infinity to infinity. And the range, as we mentioned before, it can only take positive values. The domain will be any values from negative infinity to infinity because it can take any values of x. The range, we can only take positive values for y. So we write from 0 to infinity. And that's all the properties and characteristics of exponential function. I hope you find this helpful. Thanks for watching.